All right, let's get started. All right, so I'm Stephen Diamante, and welcome to the Raleigh Software Craftsmanship
All right,
community. Let's get started. All right, so we're going to be talking about long methods and refactoring, and my very big goal is just to have long methods just disappear. I know it's kind of impossible, but at least we can try to spread the things that we learn with others and, you know, eventually get to a place where clean code is known, uh, you know, across the land. So this is also a pragmatic introduction to refactoring. If you have no knowledge of refactoring, I think this is a good place to start with long methods. And yeah. So yeah, I love the refactor. It's awesome. I love test room development as well. I've been doing extreme programming for for a while now, and mostly only been on XP teams. And now I'm on a Scrum team, but we, try to bring in the XP practices and the technical practices and all that. So I'm very passionate about technical excellence. Love learning about better ways to design software, better ways of testing, and really just love learning and teaching others. And I've been doing a lot of teaching on my team recently with doing different learning hours and collaborative learning, mob programming, and that's been really fun. Really love that. And I'm the organizer of this community. So if this is your first time here, welcome. So in today's session, I'd like you to, if you were to walk away with a few things, hope you'd be able to identify long methods, because if you can't identify the problem, you can't solve it. And also be able to apply the appropriate refactorings to those long methods. Several different ways to do that, and we'll go through some. And also be able to explain to someone why refactoring is beneficial. And also be doing a demo as well. So it'll be a lot of code. So let's just level set on some definitions. So what is refactoring? So definition that I'll throw out here today is that it's changing the structure of the code without changing its observable behavior. So this is imagine this is like Luigi and he works in a restaurant, and at the end of the night, he cleans the oven and the fryer and all the tables, mops the floors, and gets ready for the next day, right? It'd be nice if we all do that on our code bases as well. And so that's kind of what refactoring is, right? Like he's not changing the behavior of the restaurant, he's cleaning it up. And maybe they're doing some redesigns. They might change some light fixtures around. They're not changing the behavior of it. They're changing the structure. And yeah, I also think about like yeah, just like Maria Kondo kind of tidying up, um, you know, throwing away dead code is a lot like, getting rid of some of your old clothes. So here's a graph of like why refactoring is beneficial. And so over a long period of time on a project, if you don't if you don't deliberately focus on the design, and you just kind of have no design, you don't really try to improve the design, then it becomes very tough to add new features. Fortunately, this is a big problem. And so refactoring is a way to combat that. So extreme programming, merciless refactoring, is a value habit that we have, and that we're refactoring all the time. And in test-driven development, we refactor after we write some code. So it's kind of just always doing that, right? So refactoring is simply making it so that your code is easier to change in the future. So let's talk about what refactoring is not. So refactoring is not fixing a bug. I've heard a lot of people say that, they refactored something and got rid of the bug. And I'm like, wait, no, I always make sure to stop them. Like, that is not refactoring. That's just fixing a bug. They're different, right? So fixing a bug, there's some behavior that you didn't want to happen, but you changed it to make the thing that you do want to happen. So deleting code and rewriting it, not refactoring. It is a rewrite, but to really make sure that you're retaining the behavior, you want to be making small steps and kind of transforming the code, not just deleting it and thinking that you can rewrite it to have all the same behaviors. So I personally would not count that as refactoring. And this is one that I hear all the time, is that someone will say, oh yeah, I didn't, I need to rework that feature. I kind of missed some things and I need to just go back and refactor it. And what they really are saying is that they're going to add some of the behavior that they missed. They missed some acceptance criteria and they're going to like rework it. And they'll say that they're refactoring. And again, I stop them and say, no, that is not refactoring. Refactoring does not change behavior. So another important definition here is code smells. So code smells are the problems, and refactorings are the solutions to those problems. And so code smell is a symptom of a poor design or implementation choice. So here are some from a website. I'll just throw in the chat now. So you can check that out later. And I'll throw in the Discord channel as well. So that's a nice catalog of all these code smells. So here's some of them. This is basically duplication. That's a code smell. Today we'll be looking at long methods and conditional complexity, a lot of different nesting and ifs and different kind of ways that your code could go. And long parameter list, there's going to be a little bit of that today. And large class and temporary fields. We'll see a lot of that. So these are all code smells that if you resolve those, you're going to most likely be improving your design. Another great thing about code smells is that it gives us a language that we can communicate to other developers with. So instead of just saying like, I mean, this code, there's something about it. I'm not sure what's wrong with it. We can really have like this language and say, oh, we need to get rid of that temporary variable. And, there's some duplication over here. And I see some feature envy, right? And so really having those kind of abstract terms is effective in the way we communicate with each other. So I'm going to do a little activity here. Just put it in the chat. How many lines do you think that it takes for a method to be considered too long? So just throw in a number. Is it like, if it's more than 100 lines, is that too long? Or what makes you think a method is too long? So Michael's saying 20, more than 20, and Pete's saying doesn't fit on one screen. Charles is saying it's 50. depends on the language. It's not about the number of lines, about the responsibility and things the function does. That is right on. And that's yeah, I would say there's no number, right? So there's a great quote in Martin Fowler's Refactoring book. He says the argument that makes the most sense to me, however, is the separation between intention and implementation. If you have to spend effort into looking at a fragment of code to figure out what it's doing, then you should extract it into a function and name the function after that what, right? So yeah, like if you don't understand what the code's doing and there's a comment on top, and a lot of the times you can just end up naming the function after that comment if it's good enough, right? And then we're starting to get to a point where our code kind of reads like a book, and we can even show it to business people, right? Like that would be nice, right? And that business people wouldn't be scared of the code, and they would actually understand it, and it would express the domain language. So this is some sample code. This is an application that I wrote. I love football and I play a lot of fantasy football with my friends. And I just made a little tool just to like send me emails every week about like the best performing fantasy football players. And so you can see, you can kind of read the code. Like if it is the off season, it's going to send a draft rankings email, right? And if it's not, then it's going to send all these emails. So you don't know what the underlying implementation is, but if you want to know, you can go into those methods. And this is an idea called um, the step down rule that Robert C. Martin talks about, and it's also referred to as a composing method. It's just a method that calls other methods. It does have a little bit of conditional here, but it's mostly just a method that calls other methods. So yeah, in clean code, Uncle Bob, he says, we want the code to read like a top-down narrative. We want every function to be followed by those at the next level of abstraction so that we can read the problem. Descending one level of abstraction at a time as we read down the list of functions. I call this the step-down rule. So let's talk about why. Like, why are long methods a code smell? Well, methods should do one thing. And so our brain only holds about 4 to 6 pieces of information in our working memory. And so if I have this big blob of code, I can't really see like what goes with what, and I have to keep all that context in my mind. So if we can start to extract some methods and really put some meaning behind them, then we take the load off of our working memory and we really have the code express what it's doing instead. And this is very important because we need to communicate, and we communicate through our code. Like that's one form of communication, right? And so we want our code to like tell a story, say what it's doing, and short methods are great for communicating intent. And because we work with others, this makes everyone's life easier. And also long methods are a code smell because they're really hard to name. If you ever had trouble naming a method, it's probably too long if you can't like figure out exactly what it does. And so you might want to extract some methods and then find what is the underlying concept that bind those together. Some other things is that inputs and outputs become a lot clearer once you get rid of long methods. And long methods are usually the first code smell that I go after, because once I can clear out some of that, other code smells start to emerge. So some refactoring tips. Um, and these are tips that I'm going to be using today. So always start with a high quality test suite. I actually did this presentation in October, and when I was preparing for it, I did not have any tests at all. And that was kind of my like, I was like, yeah, I'm going to refactor with no test because I'm going to use all automated refactorings and provable refactorings, and it's going to be totally okay. And when I was preparing for the conference a few nights before, I realized that I introduced a bug into while I was refactoring into the application. So this time around, I have a good quality test suite. So we want to be using automated refactorings when possible. That we hopefully are using the latest and greatest IDEs of the world. I'll be using IntelliJ today, and we'll be looking at some Java code. But when we can, there's a lot of great automated refactorings because humans make mistakes, right? So we want to lean on the machine when we can. And we want to keep the test passing the entire time. So, and we don't want to change the behavior. And I've said that plenty of times, but that's very important. Even if we find a bug, we want to, do that separately, or if that's, like we want to like have that separate from the refactoring work. So I would say even if you're doing some refactoring and you have some kind of pull request, code review process, I would encourage you to do a PR for the refactoring and then come back and do the behavioral changes. Now, of course, you can do like little refactorings here and there. We should refactor all the time, but those bigger changes, it's good to separate those. And also just taking small steps. Like refactoring is just a series of small transformations that chain together make a huge impact. And I really like the mantra of, aiming for better. We don't have to be perfect. We just want to improve the design. Code we're going to look at today is not very pretty, but at the end, it's going to look better. It's not going to be perfect, but it'll be better. Um, and we should commit frequently too. I always think about committing like playing a video game, like you're about to fight a big boss or do something really risky. Save the game, right? Hit the checkpoint. So that way, if you die, you can come back to that. So when we commit frequently, if we're about to do like a really aggressive refactor with no automated refactorings and we're kind of hesitant, we want to commit so we have something to go back to. And also have a goal in mind while we're factoring. It's very important just to keep focused and know why you're refactoring the code. So I'll be using naming as a process today. So I just kind of want to introduce that a little bit. And basically, if you have a long chunk of code that's basically missing, there's no abstraction to that chunk of code. But once you extract a method out of that or a part of that, you can start to name it. So we start with just naming it nonsense. We'll name it blah or pants or applesauce, whatever you want. But we name it nonsense just to kind of put it in a place. Now it has somewhat of a home, right? And then we want to start to make it more honest. When we're working with legacy code and code bases with just a lot going on, I'd rather have an honest name that tells me exactly what it does instead of a really generic, misleading name that I have to go into the method and figure out everything it does. So at least getting to this point where it's honest and complete, then you can start to do some refactoring and find better names. So like even having and all this stuff, it's fine. . . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So let's just go through the process of how we eliminate the long methods. Uh,
Steve,
yeah, was
this is
it?
Chuck. How you doing?
Yeah, good.
Good. Okay. Well, one thing I wanted to mention was the one thing I've been seeing about this, and you're right about short functions. And what it does, it makes it easy to change the architecture to add concurrency. Semaphore is a good example. You might make it a short function. You can add a semaphore around that very easily.
Yeah.
Also, there is one thing that I would worry about when having marketers look at the code and being able to read it.
Hmm.
Like you said, a DSL.
Okay.
There is some code for devices which may be very complicated for the marketeers to read because it's very low level.
Yeah.
Yeah, because
Well,
I see myself, and one of the things why I don't like long methods is, I'm sorry for interrupting, is because we
that's
had at a place where I worked, and basically what it was, we had long methods for the device stuff. Was just a list of, it's just a list of operations. Basically, they would do bit stuff and stuff like that, so it made it hard to read.
well, is there something that's using that code that's a little higher level like that? That's what
Yes,
we want to get to,
yes,
right?
but
Is
that
it
code
you
needed
don't
to be
want them
written.
reading the low level code, right? You want them reading the business domain, that functionality.
Okay,
They
I
don't
see what you
care about
mean.
the low level stuff. So they
Yeah,
don't need
okay,
to
I see what.
follow the code. You want to bring them to the code that speaks about the behavior of the system and speaks the domain in words that they'll understand.
Okay.
Yeah.
Yeah, I see what you mean there. Okay. And one other thing, don't forget, sometimes you can't do this refactoring because you got managers that are scared of that kind of stuff.
Yeah. That's why I had that Bart Simpson thing that says don't introduce bugs while refactoring. Um,
Yeah,
there's
but
a
also it's just getting stuff done and they don't want to, like for example, I worked on code bases where there's like I 20% of the code was commented out. What I would do when I get the code, I would try to get rid of as much of that as I could and make some
right.
small
And
changes.
and with these large code bases, that's kind of the strategy is to do it incrementally, do it over time.
Yeah.
The business is never going to accept that you're going to take 3 to 6 months to refactor the whole code base.
And you
That
shouldn't. I mean, they
no,
shouldn't
don't
accept
do
that. I
that.
mean, it should be, like you said, done over time.
Yeah.
But yeah, also, and what really bothers me about them being scared is they have us create these unit tests, and then they don't want to use them.
Hmm.
I mean, think about it. The unit test will prove that our changes didn't have an effect, or at least they should.
Yep. All right. We talk more about it. I got some more to cover. I'm gonna continue. All right, so we want to identify code paragraph, and I want to actually show some code paragraphs real quick. This is a Sparrowdex, and I'm gonna have some links to that at the end. This is the way that you can like kind of um, look at some different pieces of code really quickly to kind of like be able to recognize things a lot more. But I just want to show some paragraphs. So like curly braces are a good indication of code paragraphs. Like this would be a paragraph here, along if else if chain here. So I get some other ones. Yeah, something like this. A good indicator is a comment, but also like white space between. Usually developers just do this out of habit and just they want to separate different concepts. So we care enough to do that. But so that's a good indication of to extract a method out of this, right? Give it a name. Cool. So we extract a method after we found the code paragraph, then we give it a descriptive name. Maybe we start with a terrible name to begin with, and then we learn more about the code and we improve the name over time. And then we just repeat and find more code paragraphs. So coming to the point where I'm gonna be refactoring and doing a demo. This is an application that I built before I became a professional programmer. This is like on my portfolio. This is the big app that I had built at that time before I became a junior developer. And so this is a Java Swing like desktop application, and it's for tracking stocks. So you can look up different stocks. It has like charting as well. Um, it's it's pretty cool. I didn't know like what I was doing when I built it. I also didn't know anything about test or anything about design or modularity or encapsulation, any of those like good design principles. So it's a great playground for like doing legacy code refactoring and trying to add tests to very coupled classes and all that. And this also has a lot of bugs, like this stuff, right? There's like HTML. So this bug happens during the trading hours. Off hours, it works fine. But the reason for this is because it uses a web scraper. So when it scrapes the web, sometimes the tags are different depending on if the market is open or closed. So that's going to be our goal of the day, is to um, fix that bug. But before we fix the bug, we're going to clean up the code. So we're going to be looking at this one code. Excuse me, one second. I'm trying to get my slides back up. All right, so it's the sock symbol controls or it fetches the data for all of the data right here. This comes from the web scraper, and then these two moving averages, that comes from a CSV. So it's an API. So back then I didn't know about JSON and APIs. I just had a CSV that I grabbed. All right. So the long method we're looking at is pretty much all this like 260 some lines. And it all happens in the constructor. So it basically makes those two calls and then assigns all the fields right here. So I just want to zoom out a lot and just show you all of this. Uh, we don't have to understand what it does right now, but it's a lot, right? So where are we going to start first? Well, first I will show the test. Tests are using approval tests, which is a great library. It's kind of just characterizing the behavior of my system right now. And I'm using like a full like 5,000 plus, maybe even 10,000 line HTML that I got from the real web page. So that way I don't have to I don't have to use the internet or anything. I have a mock web server. And then I also, for the CSV, I have some real data being set in here. So that way, whether it's off hours or what, I can control that. So these tests cover quite a bit of code. I'll run the coverage here. And so you'll be able to see on the left side, you'll see these green bars. Green means that it's covered. Red means it's not. There are some areas where it's red. So we'll just try to be careful around those areas. All right, so we're going to start off with using our IDE to find things to fix. So I'm just using some shortcuts. We'll be using a lot of shortcuts today. The next highlighted error is a good one. So you can kind of see like what is it recommending us to do. I'm not going to do all of its recommendations, but I at least want to know like what does IntelliJ think that I should do to improve this code. So I'm not going to use Lombok. I have used Lombok in the past, and I think it's good, but I don't want to use it at this point. There's also some duplication on not found. I'm going to ignore that as well. And this is just saying that there's a lot of complexity, but I know that. This one is interesting though. It's saying the if statement has an empty body. So what I can actually do with that one is just invert right? And now instead of B or M or K, we have not. So maybe it's not the best and hard to read, but we can get that later. But I at least want to start to get some of the if blocks kind of out of the way. And so some of these are just redundant initializers. And while I'm coding, if you have any questions about what I'm doing, feel free to interrupt me and we can have a conversation about it. All right, so this one, so this one's saying that this substring, that the end, like saying that the whole length, that's unnecessary because you don't need to do that. So I can say remove argument, or if I say clean up code, it'll do it for both of them. So just did that. And then this one is saying that like this doesn't make sense because I just said it's an empty string, and now I'm checking if it's empty. So I don't need to check for that. Now it's saying you don't need that, and you don't need to return because it's the end. Right? And then I can do a optimize imports and reformat. It's usually my first refactoring that I do. And then I'll commit it. So I've already committed, so I'm not going to make any commits here. But I'll just be going to the next thing. Right, so, and I'm also using Arlo's Git notation. So a little r means that I only used automated refactorings and with the help of my IDE. So I know that it's safe. And capital R means that I had to do some manual refactorings, but they were backed by test and they are safe. And an R with two exclamations means that this is a possible problem area. And if you were doing code review or looking at the Git history after the fact, this might be a riskier refactoring. Okay, so we're actually going to start with the hardest example first. And this is an example of when you try to extract a method and it returns multiple variables. So in some languages, that's totally fine. I know like Golang returns multiple variables, so you could just return multiples and that's fine. But with Java, you'd actually have to have a class to kind of have those in. So I'm going to start with just this chunk of code. You can see a code paragraph. There's white space surrounding it. So I'm going to just extract it and name it applesauce. I just want to like give it a home and kind of clean it up, and then we can figure out the name later if we even need a name. So now I want to start to separate these because when I'm doing this refactoring, I really want to focus on these instance variables, right? All of these defined up here. I want to leave these in the constructor, and because that kind of stuff should be in the constructor, and that'll help me kind of decouple the IO from the business logic. So let's start with this part right here, all around here. So I want to do a new line here, and the input, we close it here. But we don't need to close, we can actually just close it after, right after we're done with it. So I'm gonna move that up. And now I can extract this to a method. Not yet though. It's saying we have some temporary variables. So what I'll do is use IntelliJ to move it closer to where it's being used. I can also split. I'll do that a little slower. There's a split into separate declarations. So instead of having it all in one line, and I'll start to just move these all closer to where they're being used. That's going to help me out. And I'll split again and then keep moving closer to where it's being used. Okay, and these are just flipping, so I think I'm done. All right, now can I do it? All right, awesome. So let's just give that a name right now. And so what does this method do? So we got to the nonsense naming, but now we want to scan the method and look for one thing it does. Well, I know it calls an API. So I'll just say calls API. And it's either parsing or maybe calculating some kind of close values. So I'll just say parse close values. And you could also with naming as a process, you could say like I think or and stuff if you're not really sure about if this does anything else. But I'm satisfied with this name. And this comment, I will at least just move it over here for now, but I'll probably end up deleting it later. Okay, so now we have at least one method here. And let's see. Yeah, I'm actually just gonna delete this now. So we'll have some good names later. All right, so let's do the next part. So this chunk right here. So with the newer version of IntelliJ, it actually helps us out when it's returning multiple variables. But the weird thing is, let's just say I name this result. It like gets into this infinite loop. I'm not sure why. So it keeps doing that, right? So you have to do this manually. So here's a process to do this. So I'll name a class called foo. So this is the same process I use all the time. And then I just rename foo later. So start with a class called foo. And I want to, the two things that it returns is sum 50 and sum 100. So I'm actually going to cut those and put them in this class. And I'm going to make them public. I won't worry about encapsulation. I'm just trying to improve the design, but this thing I can always come back to later. But I want to focus on what I'm doing, right? So what I'll do with this new instance I have, I'll go to everywhere that it says sum 50, and I'll put foo behind it. And I'll do the same thing over here. And now I can extract this. And so get foo is a terrible name and foo is a terrible name. So what is this doing? Sum 50 is all of the close values for the last 50 days because we're trying to get a moving average of the stock. So we can say get close value sums, and this can be close value sums. So even though I named it foo, it's easy just to rename things. All right, so now I have two little nice methods here. It's also good to make sure that they're in the same order that they're called. So I have call API and parse close values, and then get close value sums. All right, and then onto this piece. So I will just extract this part. And so now I can see that I have this currency formatter. I'm okay with temp because that's actually what I want to assign this 50-day moving average to. But the currency formatter, it's used down here as well. So what I can do is I can just inline this. So if I bring up the refactoring menu, I'll try to do a little bit more of the refactoring menu so I can kind of explain some of these, right? So inline variable is just basically the opposite of introducing a variable. So now instead of that temp variable, we just call this in both places. And that's going to help with extracting this. All right, so we'll call this either parse or it's probably calculate, but I think I ended up naming this parse 50-day moving average. And on this temp variable is not needed, so I'll just inline that. And I still have this temp used down here. So I just moved it closer to where it's being used. And we'll see if we can extract a method out of this as well. And that looks good. That's a signature I would expect here. Parse 100-day moving average. All right. And now I'm okay with just inlining this applesauce method. I don't even want to rename it. I'm okay with just sending it back up to where it came from. So now I kind of have this like kind of related chunk of code right here. And I'm just going to leave that alone. So that is kind of the hardest thing that we'll do all day. Any questions at this point? All right, I will continue. All right, so now we would go to this volume one. And so I want to show like two different ways to do this. So I can extract the whole method. Again, I'll name it applesauce. And I want to do that moving and closer usages again. It's gonna help just clean up this method, right? So I extracted a method, gave it a home, gave it a terrible name that I'll change in a second. And I'll leave that comment until I change the name. Because once I give it a good name, we don't need that. We don't need that comment anymore. I also will inline this because the document comes from JSoup. So JSoup is that web scraper that's going to MarketWatch and grabbing all that stock prices and data. So this is IO and it's hard to test. And I want to separate it from all of this parsing logic. So what I want to do is actually pass in this line instead of a document. We can do that by a refactoring called introduce parameter. So that's just gonna send in the line instead. So you see where this is called from, it now has the doc on this side. So that's giving me a more pure method that's easier to test. I could just send in some HTML, right? And I could even rename this. I'll name it volume HTML. That's a better name than line. And I can get rid of that, rename this parse volume. And one more thing is that I want to actually have this on the outside. So one way I can do is I can just return. I can do a quick fix and say, can you please make parse volume return a string? And then I need to go to parse volume and do that. So let's run the test, make sure nothing broke. So we're all good. And comment like this, I will keep that around. It's informative and could help later. I like comments that state like why, but when there's cryptic code, it is good to have a little bit more information. But this is kind of like why, you know, that's good. All right, let's move to the next one. And I'll do this one in a kind of different way. So give you like multiple variations. Okay. So this one, well, yeah, this one I'll probably do the same way. Eh, I'll just do it in here. So what we need to do with this one is it's being assigned multiple times. So what we can do is use a temporary variable, and everywhere this is called right here, I'll replace it with temp. And then at the end, then I'll assign it. So run the test. We still have the same functionality. Still good. And now I can extract this. First average volume. And I don't need this temper anymore. So do the same thing as before. Just, as I'm in here, start to clean it up. Remove this comment I don't need anymore. This can just be joined. And I'm just going to keep it as temp. Maybe you'd have a better name for this, but we really don't have any way to like kind of return this because we do have conditional using it. So I'm just going to leave it just like that. I could rename this to average volume. Oh, wait. No, actually, this one will keep as line. That's fine. All right, I'm going to probably skip ahead to this one, and I'll show how we can use replace temp with query. And we kind of already did a little bit of that in the first example. So where am I looking here? Right here. Okay, so we got this yearly low and yearly high. So let me just try to extract this. And it's returning an index. So line, I'm okay with it coming here, but it's returning an index, and I don't really like that. And let me even extract a variable out of this so that it's even more clear what it's doing. So this class it's trying to extract, substring is the thing that I want to return and assign to that, but index is not. So I need to back out of that. And there's something going on with index. Index is being used down here. So I'll use the same thing I've been doing in it's not letting me move it. So I will move it manually. And let me just run the test. All right, and let me try to extract now. So now it's saying that deci needs to be returned as well. So no, I don't want that because deci is just a temporary variable that's also used down here. So how we can solve that, if you ever get into this problem where it's just because it's a temporary variable that you need it, so you can extract a method out of this. So I can say, this looks like maybe index of decimal is an okay name for that. And I'm just going to replace all. There's a lot of occurrences of that. And that'll kind of help out with some duplication. Now, back where we were, I'm not done because now I need to inline this because I want to not use the temporary variable. I want to use the query. So now I'm calling this method in multiple places. So it's probably a little messy and it's something that you could clean up later, but it helps when trying to extract these methods. And you can always kind of bring it back in or do something else later. But right now we're just trying to put these all in, little piles of methods. So let's try again to extract this. All right, now it's saying, sorry, it was saying target, kind of backed out, but it said it was also returning target. So target's a problem now. I'll do the same thing. Say index of 52-week range. And now we have to inline it because it's used down here, over here. So we will use the query and not the temp. Don't want to do that. I'm going to do that. And now this is the signature that I'm expecting. I'm passing in a line of HTML and I'm getting back this thing that I'm going to assign to yearly low. Now we'll call this parse yearly low. And I don't need this substring anymore. And let's see how this is looking. Are we able to extract this? That looks good. So this is fine as well. Doesn't have any temporary variables. So that is good. So then we end up something like this. All right, so let's probably skip ahead a little bit. Just for the sake of time, I'm gonna skip a little bit ahead. I will just briefly talk about the risky thing I did, which isn't that risky. Basically, we were returning when it was empty, and I chose to throw an exception instead. But that's totally fine because we're gonna try catch. So it's kind of like the same as returning. So I would probably just, kind of flag this on the code review, or if we were pairing and saying like, I'm kind of worried about this, and that's why the 2 exclamation marks are there. All right, so let's look at what we have now. So if we're just looking at this method here, this is now 32 lines, a lot better. So we could definitely stop here, but this class is still hard to test. I was able to get a test with it, but I needed 2 mock servers and there's still all this IO, right? And so what we can do is I've kind of put these into different categories. Like this is kind of like the current stock data, right? This is like the stock name, the price, like this is everything that's like right now. And then some of this stuff, this is kind of the historical data. Maybe even the open, the low, and the high are current stock data too. Just thinking about that now. But I've already done this refactor. But yeah, I think this probably belongs there. But this is kind of the historical stock data. And but the real separation of why I made these is because this only needs this HTML, and this actually has a few different tags that it uses. So that was the original idea of the separation. And then this one right here, this doesn't use the web scraper at all. It's totally different. It uses the CSV. And this one can be like a moving averages. So extracting these into classes, we would want to extract these into classes and all that. I'm not gonna show that. I'm probably gonna wrap up the presentation. But I will just show the final form of this. So we can see like where we came from and what we ended up with. So now we have about 18 lines. And the IO is separated. So the doc is sent in like here, like this current stock data. It just takes a bunch of strings and those are HTML. And current stock data has text. And we can just send in the HTML that we need. We don't need a 10,000 line file of HTML. And we can start to solve the bug. So this is the bug being solved here. And so I wrote a test for it, it failed, and then we were able to change it. And with historical stock data, this just has one field. And it just has all the different parsing methods in it. And to make this stock symbol still compatible with the rest of the app, because these getters are like used in the presentation layer, right? Like this stock form is the actual form that the table that you see, right? So we don't want to change these. So instead, we're just delegating over to the current stock data to parse the price. And I've even just gotten rid of those different price and stock symbol variables entirely. So the stock symbol has a current stock data and historical stock data and moving averages and a URL. That is pretty useless, but as I said, this isn't perfect now, but it's a lot better than what it was. Right. So and after some practice, like this kind of stuff, you'll be able to do this uh quicker and more efficient and without errors. And really the more and more you practice with this stuff, the better it gets. So yeah, let's talk about what we did. We took a 260 line file and we reduced it down to about 17 lines. And those lines are in other places, but we've increased the cohesion. The things are together that make sense to be together. And we've also done a little bit better job of separating IO behavior, network calls from actual business logic in the parsing logic. So did a lot of extract methods. So whatever IDE you're using, check out the refactoring menu, learn your tools, practice, try to utilize those and also learn the shortcuts. Because if you're thinking about, right clicking and going to the menu, it takes so much time. But if you can have these commands just at the tip of your fingers, you don't even have to think about it. You're thinking about the next move and the big picture, right? So the more and more you practice, the more automatic and quicker you can just flow through an idea. And then it also makes backing out a lot easier because it didn't take you much effort in the first place. So when we extracted methods, we named things with terrible names. I named things with pants and applesauce because I knew I could rename with just a Shift F6. I was just one, you know, one shortcut away from renaming. So we can approach naming as a process. So we can gradually improve the names as we learn more about the code. And we use quick fixes from IntelliJ or any other IDE that you're using has these kind of things where it can help you. So I used a lot of move declaration to closer to the usages, and that helped out a lot. So when we're extracting like average volume, we use a temp variable to be able to kind of separate the parsing from the assigning of the instance variable. Oh, and multi-cursor select, which is pretty awesome. Replace temp with query in the yearly low and high. Like Deci and Target were being returned, but I didn't actually need to create a whole new class because they were just temporary variables. But I was trying to separate yearly low from yearly high, but they're both using the same, right? Coupling. So instead, I replaced the temp with a query, and I made a method that could just query it. So we have index of decimal and then the index of the 52-week range. And then the first example that we looked at was extracting a method that returns multiple variables. And so I use that like foo class just as a kind of placeholder. And if I do that, I just do that the same way every time, and I'm able to get around this. And in the end, let me just show you for those that might not like that lack of encapsulation. I ended up making this private and final and cleaning up some of it and giving it better names. And after I had some tests around things, I was able to like even better test around things, was able to improve. But the lack of encapsulation here is not a problem in the beginning, in the short term, because we're just trying to take this long method and start to separate things and kind of put them into groups, seeing where everything belongs. And then a huge thing, this is a huge problem I see all the time, is that there's IO and business logic together. I don't normally see this in like data classes constructors like I have here, but I see it all the time in services. I see these big services and Spring Boot that they'll have database calls and API calls, but then they're also the business logic is in the middle. Trying to test that stuff is a pain. And so if you could, if you can just focus on separating the network calls and the IO from the business logic, that'd be a huge win. A lot easier to test, a lot easier to understand what are the important parts of your code, and then what is just like infrastructure, like the outside world, right? So we were able to do that in huge part from extracting this class, the current stock data. So I've been talking a little bit about practice, and this is deliberate practice that I'm talking about. That you find a small problem. Don't start on your huge code bases, but there's a lot of refactoring katas and different things that can start to get you in the rhythm of refactoring and have you practice some of these things. That maybe you're good at some of this stuff, but there's other more advanced refactorings that you still need more practice. So having that deliberate practice and saying, okay, I'm going to spend like in 30 minutes or to an hour, and I'm going to work on replacing conditional with polymorphism. And I'm just going to do that over and over and over again. So that kind of practice is um is great to be able to have these steps become automatic and just second nature. And that starts to help the problem of I can't refactor this code because my manager won't let me, but I am able to do this all the time and I'm able to improve the design that the manager's loving it because we're delivering so much faster. And hopefully that ends up being the story that we're able to tell. So yeah, as I said, practicing on katas, I'm gonna have some resources for some different katas. You know, there's small exercises. They're not, you know, they're usually designed to practice a specific thing. There's a lot of different factoring katas, and I would highly encourage you to practice on those before trying this on your code bases if you're new to this, right? If you already have experience, you know, go for it. But you don't want to get in that position where you try to refactor and you haven't had enough practice and things don't go well. Because the last thing that I want for any of us is for uh, our team and the business, the product owners to say, hey, you're not allowed to refactor anymore because last time, you know, you introduced a bug or it took a long time and we have deadlines, things like that. So practice, practice, practice. And share these ideas with your team. My team takes 2 hours a week where we do these kind of katas. We've been doing a lot of refactoring now. I'm on a team where we're all new to the code bases. We've kind of inherited all these different like 12 different applications, and it's just got a lot of coupling, a lot of spaghetti code going on. And so TDD is not realistic for us to focus on, but refactoring is key. So yeah, learn with your team. And Scratch refactoring, I did that a lot on these new code bases I was telling you about that that just start refactoring and have no intention of committing it, that you're just going to just go wild, right? And you don't worry about making mistakes. You're just kind of like playing with the code. And at the end, push it on some branch that no that's never going to make it to master branch or just wipe it out completely. The important thing is the learning that you've done. And it also helps to learn new code bases. I'm able to, instead of just like reading a code base, like, and I just start refactoring it and it makes me learn it so much more easily. Yep. So here's some resources. There's Sparrow decks. And just pull this up real quick. Let's look at long methods. So this is kind of like interactive one, but you basically just like go through this and be like, okay, too long, and it'll give you too long, too long, short enough, right? And it gives you some feedback. And there's also a whole learning hour on this. So learning hours. There's a whole learning hour where she has all these.
Long.
Right. And over time it gets faster and faster. And at the end of it, you're not even thinking about it, right? It's just automatic, like too long, short enough, right? And you're able to like instantly recognize these. So I definitely recommend checking out anything from Emily Bache. She's a technical coach and has tons of resources that you can share with your team. These are guided learning hours. You can play these in front of your team, have a little Miro board set up. She, has intros for the facilitators to be able to teach you how to be able to teach your team these things. So highly recommend that. If you have any question about that, definitely reach out to me and I can help you get started. Refactoring katas. There's a bunch here. There's a bunch all around. Just Google it. You'll find some stuff. Tennis refactoring kata is one of my favorite katas to do. I made a YouTube playlist, so you can check that out. And I'll put these slides in the Discord, and probably put them on Meetup as well, so you can check out the slides. And naming as a process, we talked about naming as a process very briefly, but this is a blog series by Arlo Belshi, who will be joining us next month. Very excited about that. And this is a great read. I would share this with your teams. Just really change the way that you think about naming. I used to spend, so much time naming methods, and now I just name it and come back to it, and the names get better over time, and it's great. And then this code that I worked on today, you can go through that. You can. I just told you my code base is very messy, and if you need some practice code, I think that's a great place to start. So that's all I have for you. Let's see if there's any. Let me look at the chat. So what ID is that? It was IntelliJ. You were making fun of Java. Okay, horrors of mock web server. Michael, you want to explain that a little bit more? I don't know. Pure parsing tests are gonna run much faster than you mocking the network. Yeah, definitely. Yep. Yep. So
Thank you for a great talk.
appreciate it. Thank you. Yeah. Yeah. So the rest of the time we have here is just Q&A. If you want to talk more about refactoring, or Charles, if you want to continue the conversation we had in the middle there. Hopefully I was able to give you some more tips on how you can I watched a talk recently by Martin Fowler. He was saying if you're at the point where you're even asking permission or talking to your manager about this, you're already you're already in trouble. This is part of our job. We are the professionals. We are the problem solvers, and refactoring is a way to make change easier for our code. So that's the best thing to do. We're the ones that know to do that.
Yeah, but a lot of the teams I've worked on have never done that. I did it myself, to try to get, the code clean.
Yeah, no, it's hard. There's people like us that will come to a meetup on a Tuesday night, and we'll try to improve our craft because we really love what we do, and it's more than a job to us. And there's other people that it's just 9 to 5, and I'm not gonna put in more effort than I need to. But all I could say is that just keep sharing and try to encourage people, inspire people. And I really think learning together is the best, because I always try to just I always try to tell. I tried when I send like videos, I'll send like talks and blogs to people. They never read them. But then I started doing um these sessions like once a week, and sometimes we'll just watch a talk together and then we'll talk about it afterwards. And yeah, I think those kind of like learning opportunities as a team is great. All right, so Michael's saying, are the refactoring katas like code wars? Will I be able to practice in different languages? Yeah. Yeah, let's look at that now. Yeah, a lot of these have the Gilded Rose is a very popular one here. So you can oh yeah, so what is your language, Michael? Didn't you say it was Haskell? Yeah, Haskell. So there's so many languages on this one. Not all of them have like this much, but this is like one of the most popular refactoring katas. But yeah, there's a lot. I mean, Emily has so many. Like these are TDD katas and refactoring. There's legacy code katas. Yeah, Haskell, my beloved. Yeah. All right, Michael's learning JavaScript. Yeah, definitely a lot of JavaScript, TypeScript stuff that you can do. Yeah, if you ever want to talk about katas, join our Discord, send me a message, reach out to me on LinkedIn, and I love talking about this stuff. So, oh yeah, and Peak put in Cyber Dojo. That's a good one too, because then that way, Cyber Dojo, Michael, if you're looking to try out other languages, you don't even have to have that set up on your machine. You don't have to, you just go to Cyber Dojo and you can pick whatever language you want to work with and just start doing some small exercise in there. So that's super cool. The Discord is in the meetup. Set a comment down there. I can get that in a second. So I'm going to